Have you ever really thought about how simple grape juice turns into a complex aromatic wine? You know, it kind of seems like magic, but it's actually a super carefully orchestrated biological process, and it's all powered by an invisible army of microscopic workers. So let's pull back the curtain and see how this all really works. You see, in every single batch of wine, there's an unseen war going on. It's a battle that decides if that wine is going to be vibrant and beautiful, or just dull, brown, and frankly, flawed. The outcome all comes down to a microscopic fight fought by these tiny biological machines. And that's exactly what we're diving into today. So, who are they? Who are these invisible workers, these soldiers fighting on the front lines of flavor? Well, they're called enzymes. That's a great, simple definition. I like to think of an enzyme as this tiny, highly specialized machine. Its one and only job is to make a specific chemical reaction happen, and to make it happen way, way faster than it would on its own. They're pretty much the ultimate efficiency experts of the natural world. So where do these little machines come from? Well, mostly two places. Some are just naturally there in the grape, kind of hiding out in the skins and the pulp. But others, they hitch a ride on the outside of the grape. They come from all the yeasts, fungi, and bacteria that live there. And as we're going to see, both of these sources play a huge part in how the wine turns out. But here's the thing. These enzymes aren't just running wild. They are incredibly sensitive. A tiny change in temperature or acidity, the pH, can either supercharge their activity or shut them down completely. And this sensitivity, well, that's a crucial lever that winemakers have learned to pull. But here's the twist. Not all of these enzymes are on the same team. In the world of wine, you've got your heroes and you've got your villains. And yeah, this really lays out the two sides perfectly, doesn't it? On one hand, you have the heroes, working hard to unlock amazing aromas, clear up the wine, and feed the yeast. But then you have the villains, doing the exact opposite. They cause the wine to brown, they create this ugly haze, and they literally destroy the color and texture that we all love. So let's talk about those villains for a minute, and the number one problem they create: oxidation, or what's known as the browning problem. Okay, so there are two main culprits here. First up is tyrosinase. It's always in the grapes, it's the reason a cut apple turns brown. But the real supervillain is lacase. This one only shows up when grapes have rot, specifically something called Botrytis cinerea, and it is way, way more destructive. So the key thing to get is this. Tyrosinase is a problem, for sure, but lacase is a full-on catastrophe. It doesn't just make the wine brown, it aggressively attacks the very things that make wine beautiful. The anthocyanins, which give you that gorgeous red color, and the tannins, which give it that structure, that feeling in your mouth. And this number really drives home the difference. A little bit of sulfur dioxide, or SO2, can knock out 90% of tyrosinase activity in just a half hour. But lacase? Nope. It pretty much just shrugs it off, which makes it so much harder to control. So how do winemakers fight back? Well, it's kind of like a three-pronged attack. First, they have to be super careful and sort the grapes, pulling out any sign of rot to keep lacase out of there in the first place. Second, they use SO2 to take care of the tyrosinase. And third, they can use clarifying agents like bentonite clay, which literally grab onto those bad enzymes and pull them right out of the juice. All right, enough about the villains. Let's turn our attention to the good guys, the heroes of our story, the amazing enzymes that help create a beautiful wine. First up, pectinase. So pectin is this natural stuff in grapes that makes the juice kind of thick and hazy. Pectinase acts like a pair of molecular scissors, just chopping up that pectin, thinning out the juice, and making it way easier to get a brilliantly clear wine in the end. Next, we have glycosidase. And this one is all about aroma. So many of wine's most beautiful smells, like those floral notes you get from compounds called terpenes, are actually locked away, chemically stuck to a sugar molecule. Glycosidase is the key that unlocks them, releasing all of that incredible aromatic potential right into your glass. And finally, we've got protease. This hero is a real multitasker. It has two jobs. It breaks down these big, clunky proteins into smaller, useful amino acids, which, it turns out, is essential food for the yeast. And at the same time, it stops those same proteins from clumping together later and causing a cloudy protein haze in the finished bottle. So we have this whole complex world of heroes and villains going at it. But this isn't just chaos. And that brings us to the final piece of the puzzle, the winemaker, who is basically the conductor of this entire microscopic orchestra. And that's really the main thing to remember here. Winemaking isn't just about, letting nature take its course. It's about understanding these tiny battles and stepping in at just the right moments to steer the whole process toward a delicious outcome. The winemaker has a few different tools at their disposal. They can inhibit the villains with careful sorting and smart use of SO2. They can enhance the heroes by adding special commercial enzyme preparations. They precisely control the environment, the temperature, and the pH to give the good guys the home field advantage. And timing. Timing is absolutely everything. Some enzymes have to go in early, before the alcohol from fermentation shows up and shuts them down. And this slide really shows you just how profound this whole transformation is. Just take a look at the vitamins. Thiamine, or B1, it starts out pretty high in the grape must, right? But then the yeast consumes almost all of it during fermentation. And at the exact same time, look at riboflavin, or B2. It actually increases because the yeast is busy making it. It's a total chemical rework. So why does this even matter? Well, because these vitamins are essential growth factors. They're like superfoods for the yeast. Without these key nutrients, the yeast and all the good bacteria doing the fermentation just can't do their jobs right. You could end up with a stalled or flawed wine. See? It's all connected. So we've seen the invisible battle, we've met the heroes and villains, and we've seen how the winemaker conducts this whole symphony. It all leads to one final thought. The next time you pour a glass of wine, and you're admiring its clarity, that rich color, those beautiful aromas, will you take just a second to think about that invisible army? The enzymes that worked and fought and honestly sacrificed to make it all possible? Thanks for joining us for this explainer. Cheers!